How to read inequalities. When we read inequalities, we follow the direction of the symbols and say it in words. Let's look at a few examples with variables and negative numbers. Example number 1. X is less 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 than negative 2. X is less than negative 2. That means x can be negative 3, negative 4, negative 10, or every number less than negative 2. Another example, if we have x is greater than or equal to 10. So x can be 11, 12, 20, or every number greater than or equal to 10. Another example is a is greater than 0. A can be every number greater than 0, but never 0. If we have a is greater than or equal to 0, a can be 0 or every number greater than 0. For example, 1, 2, or 100. What is an inequality? An inequality is a mathematical statement that compares two values instead of saying they're exactly equal. Instead of using the equal sign, we use symbols show if something is bigger, smaller, or equal to. The main inequality symbols are these symbols are greater than, this is less than, this is greater than or equal to, and this is less than or equal to. For example, x is greater than 8 and x is greater than or equal to 0. Inequalities are useful because many situations don't have just one exact answer. Instead, they allow a range of possible values. We use inequalities in real life all the time. If someone says you must be at least 18 to vote, that means age is greater than 18. Another example is the temperature must stay above -5. Temperature the temperature is greater than -5, or another example, the maximum capacity is 15 people. The people is less than or equal to 15 people.
For example, if 6x rated if it means x can be any number greater than 5 like 6, 7 or 10, but 5 is not included. If I say x grade of equal to 5, now 5 is included, say x, so x can be 5, 6, 7 or so on. Let's try another one y less than 3, that means y can be any value than 3 like 2, 1, 0 or even minus numbers. Now here's same thing, very important. When we solve when including it, we must follow the same rules as equations. But there's one spell rule. I multiply or they both say about minus number, we have to fit the inequality symbol. For example, if we have minus 2x greater than 6, we divide side b minus 2. The gauss of x less than minus 3. Notice how the graders that is x less than minus 3. Notice how the greater the symbol checking less than. We can also graph including it a number line in the number is included, like in x greater or equal to 4, we is a closed circle on 4, and the number is not included, like x greater than 4, we use an open circle. Sometimes we can have inequality with function. For example, x over 2 less or equal to 4. To solve this, we multiply both sides by 2. That goes is x less or equal to it. We can also have inequalities with variables on both sides. For example, 3x plus 5 greater than 2x plus 9. If we subtract 2x from both sides, we get x plus 5 greater than 9. Or now subtract 5 from both sides, x greater than 4. So the solution is all numbers greater than 4. Or we can also describe inequalities using interval notation. For example, x greater or equal to 2 is written as to come infinity. The bracket letters means the number is included. The parentheses bracket means the number is not included. So x greater than 2b warrants to common infinity. Another important common inequalities. For example, 1 less than x less than 5. This means x is greater than 1 but less than 5. On a number line, we draw one open circle, one open circle, and 5, and shade the region in between. Sometimes inequality can also be written with or. For example, x less than magnitude 2 or x greater or equal to 3. This means the solution has two parts, a number less than minus 2 or a numbers greater or equal to 3. Recap: we can solve inequalities just like making sounds one flip the same if we multiply or divide by a minus. We can graph the wings open or closed circles. We can read them in interval notation, and we can combine the use.
Okay. Suppose we have this inequality, 3x plus 2 less than or equal to 11. Yeah. We want to find the values of x that make this true. We solve it step by step, just like an equation. Step 1. Subtract 2 from both two sides. 3x plus 2 minus minus less than 2 less than or equal to 11 minus 2. Yeah. So we had 3x less than or equal to 9. Yeah. Step 2. And now divide both sides by 3. Yeah. And 3x divided by 3. Yeah. Less than or equal to 9 divided by 3. Yeah. Yeah. That guy is less than or equal to 3. To 3. Yeah. X less than or equal to 3. Yeah. Demands x by x can be 3 or a number smaller than 3, like 2, 1, 0 or minus 5. Another example. Yeah. Solve the inequality. 2 times x plus 3 minus 4, yeah, less than or equal to plus 5. Yeah. Step 1. Distribute the terms. Yeah. 2 times x plus 3 less than or is equal 2, x plus 6 minus 4, which is equal 2x plus 2. Yeah. So the inequality becomes, yeah, the 2x, no, 2 2x plus 2 less than or equal to plus 5. Yeah. Step 2, move variables to on side. Yeah. 2x plus 2 minus x greater than or equal to plus 5 minus x. Yeah. X plus 2 less than or equal to 5. Yeah, or equal to 5. Step 3, move the constants to the other side. Yeah. Plus 2 less than x plus 2 less than or equal to 5 minus 2. Yeah. We x final solution, x less than or equal to 3. Yeah. X less than or equal to 3. Final solution. This means that any number greater than or equal to 3 satisfies the inequality. Hans has here example. Okay, inequality to solve. 4x minus 7 less than 13. Okay, solution. Step 1, had 7 both sides. Okay, to both sides. Okay, 4x minus 7 plus 7 less than 13 plus 7. Okay, it's like 4x less than 20. Okay, result. Step 2, divide both sides before. Okay, it remains I and x less than 5. Result final. Okay, final result x less than 5. Okay. Final answer are the values of x less than 5. Make the inequality true. Examples equal x equal 4. Yeah. Okay. An example, x equal 0, x equal 4, 3, 2, 1, 0, etc. Yeah. In conclusion, inequalities are a key part of mathematics because they allow us to compare quantities and describe range or possible values instead of use one exact answer. By using symbols like greater than, less than, greater than or equal to, and less than and equal to, we can express limits, conditions, and real-world situations such as age, measurements, money, temperature, and more. Understanding how to read, interpret, and solve inequalities help us make decisions, set up boundaries, and solve problems both in math and everyday life.